Okay, so first unit is all about limits. So limits, what it is as you approach an x value, you're trying to figure out what's going on with the height. That's what you're doing. So last year you were learning about graphing something like a rational function. Okay, you know that asymptotes could exist, points of discontinuity can exist. So sometimes in graphs we can't get exactly where we want to go, but we can tell you where we're heading. Okay, does that make sense? Okay, so here's 4 strategies. Sometimes you can just substitute it in. Sometimes you could substitute near that number. Sometimes you could use algebra to eliminate an issue. An issue is often dividing by 0. That's an issue. And we could analyze what's going on. Okay, so here is an example of method 1. What is the limit to this function as x approaches the value 5? So this is what that format means. What's the limit of this function as x approaches 5? So I can just plug the 5 in. And what are we getting? 60? Okay, number 2. I can't use substitution. Do you understand why I can't substitute a 7 into this equation?
Because then
the bottom 0, which means my answer would say undefined. Okay? So now what I'm going to do is method 2. We're going to, actually, I'm going to show you 2 different methods. We're going to do the numbers near. So the numbers going towards 7. I'm going to pick an x value of 6.9. I'm going to pick an x value of 6.99. I'm also going to pick an x value of 7.1 and 7.01. Okay, so I'm just picking a bunch of numbers that are close to 7, but did you notice how I picked them on the underside and the overside of 7? Okay, Raiko's row, you have this one, the first one. Okay, Reese's row, you have the second one. Syra's row, you have the third one. And you too. You have to plug a 7.01 into that. Tell me what you get. Make sure you put brackets on when you do the divide by brackets. So plug that x value into the equation and see if you get a number. Make sure you do your brackets, divide by brackets. Okay, first row against the wall there. Anybody feel confident in their number? 13.9. Second row? You got a 13.99. Anybody in the third row here get a number? 14.1? 14.01. Okay, if you saw those y values, does anybody have a conclusion of what our height might be getting at right at 7 then? The limit, the height is going to approach 14. So I just plugged in a bunch of x values close to 7. But when I did that, I'm always doing it on both sides of 7, a little below 7 and a little above 7. Okay. I can algebraically eliminate the problem here as well. I could have done that. This is another method. Is there any algebra stuff anybody can see with any part of this?
Oh, DOS.
Difference of squares. So x plus 7, x minus 7. Which means that could get canceled. So now, if it's gone, I can actually do what? Plug a 7 right into that. So into this equation, if you plug a 7 in, what do you get at? 14. Okay, who remembers from pre-calc what this would mean on a graph? It's a hole. X plus 7, if I graphed it, what kind of shape would it make? It would make a line. And what do you know? At 7, at the x value of 7, there's just a hole in the line. So can you see what a limit is? As I travel on this line, as I get closer and closer to 7, the height gets closer and closer to 14. It never, ever, ever touches the height of 14, but that's what it's close to. Okay, so this one, you could probably pick both methods again. Do you want to do both, or do you want me to just do one? You could pick numbers close to 5 again. I feel like that method could really almost always work. Okay, but I'm just going to do eliminating the problem. If I can eliminate the problem, x minus 5, would you see that I could factor the bottom? So this is why I can't plug a 5 in, because I'm making a division by 0, and then you're getting an undefined answer. So that goes away. So now, if you plug a 5 into this equation, what do you get at? The limit reaches 1/7. And again, there's a hole there. That's why. Okay, analyze what's happening. Okay, so here's what's going to go on. You have to remember your rules from rationals. Should we write them down? Do you remember them? Rational rules. What do we know? What if the degree is higher on the top? You don't have any restrictions, right? So If you don't really have any restrictions, you can just be infinite, right? What if the degree was higher on the bottom? Yeah, horizontal y equals 0. That's where we went to. And then what was the other rule? If the degrees were the same.
Divide the coefficients.
It would be at some kind of number, right? Yeah. Divide the coefficients and you're just going to reach a value, a certain value, whatever that would be. Okay? That's going to come into play with this when you analyze. Okay, so what are you noticing right away here? Same. Okay, so I want you to think about this. If they're the same and x is approaching infinity, think about big number, right? Like, what if the top became 4 billion? Then the bottom would become 1 billion, right? Because they're the same. So then it would approach 4, okay? Why didn't I even look at the rest of this equation? Okay, once you're talking about an x squared and an infinite number, these are like a little drop of water in an ocean. Okay, the x squared is really all that matters. Think about the number 4,000,000,001 or something like that, right? It's almost irrelevant because it's so small. Okay, so if these are the same, it's like saying 4 billion divided by 1 billion. Okay, what about this one? So you can think about the degrees stuff. Higher on the bottom. So what's this number? As I keep going on forever, as x just gets bigger, what's going to happen to the number? It's going to approach 0. So you can think about squaring a number and cubing a number. Okay, this one's getting bigger, bigger, so your number's getting smaller, smaller. Or you can think about 1,000 divided by 1 billion. Like, that's a small number, right? Okay, so this one, what's happening with, like, let's talk about degrees. I can notice it's higher on the top, right? So what's happening to my number? So if I'm doing a big number cubed divided by a big number squared, what's eventually going to happen to this number? It's just going to get bigger and bigger and bigger, right? So then if it's just going to get bigger and bigger, then that's going to be the answer. Okay, let's do a little bit of harder ones now. Okay, first example. I obviously can't plug a 0 in for the h in this equation because now I have a divide by 0. Okay, anybody want to suggest one of the methods? Should I can't use substitution. Do you want to plug in numbers close to 0 or do you want to try some algebra stuff? I'm thinking algebra stuff. Okay, can we do some squaring on this? Can you square that trinomial? Square that. Everyone's good? Where I got that from? I squared it. Now what? What do you see would work? What could you do next with this? What about 16 subtract 16? Would that help us? That. So that's gone. Now there's some algebra I could do on the top. What do you recognize? GCF. So without that, I could take an h out of those two things. Now that gets me to cancel something. And now I can do substitution here. Okay, so what happens now if I plug an h into this line? You get a 8. Okay, example 2. You can't plug that in. It's not going to work to plug in. Do your calculators even do absolute values? I don't even know. But 0 to a 0, did you know you can't plug that in? Okay, so we can't do a plug-in. I can tell you there's no algebra here, right? I can't see anything, like factoring, nothing. So what's another method then, if you can't do those ones? Close numbers. Okay, so you're going to have to pick a number a little bit below, a little bit above. So I'm going to go -0.1, -0.01. Those are like the underneath it. And then I'm going to go +0.1, +0.01. What does absolute value mean though? No negative, like if I do the absolute value of -0.1, it's really going to be the same as that, right? So I guess there's no point in doing that, right? Because this, whatever this number is, it's going to be the same as that. Okay, can you plug those numbers in? Go 0.1 to a 0.1. 0.1 to a 0.1. You know what, I'm going to do another plug-in here just to make sure I understand what's going on. I'm going to go 0.001. If I keep going closer and closer to 0. Okay, after you've done a bunch of trials, do you have a conclusion about what's going on with the height of this thing? Looks like it's approaching the height of 1. Okay, can't substitute, got a division by 0. Don't see any algebra, right? There's nothing to factor, something like that. So which method do you want to do? I think we got to go with the numbers near 5 again. So I'm going to go below 5, 4.9 and 4.99. And I'm going to go a couple numbers close to 5 above it. Okay, so then find me some y values for those. Okay, are you getting those numbers? Okay, so do we have a conclusion about where we're heading to when we hit 5? No, we don't. Are they going in the same place? No. So there's going to be no limit to that one. That's the answer. Okay, because we're not heading consistently to somewhere. So what is actually happening at 5? What do you think the graph has at 5? It has an asymptote. And coming in from this direction, what's going on? Your graph is heading negative. And on this side of 5, what's going on with your graph? It's heading positive. Right? Does that make sense from your rationals unit? It's an asymptote. You're heading in two different directions. You have no conclusion of where you're going. Okay, I'm gonna do, I think, one more then. Nope, I don't need to do one more. I think we're gonna stop.